In this video clip, let's talk about switch case. So switch case is one of our last control structures. Control structure allows you to group various different logics together, and you can use switch case to iterate them, right, and selecting the right one. So the switch statement evaluates an expression, right, matching the expression's value to a case clause and executes statements associated with that class. So let's look at, and the information about this switch case is available in your textbook. As well as in C++.com, there's a huge reference chapters about this. And then we'll examine what this integral enumeration type is. Typically, what's the integral, right? In C++, in Java, and some of the other languages, usually involves char, right? Integer, right? So in C++, we also have other modifiers saying this is a shorter int, this is a longer int. That's fine too. These all evaluate to an integer. Sometimes we may treat Boolean as an integral type as well, because Boolean evaluates to either ones or zero, right? Even though Boolean can store a number that is much bigger than one, it could be 2, -1, 2, 3, 4, 5, 6, right? So these are integral types, you can use them. And I'll look at the specific implementation detail to understand this a little more. But you can also think of the switch case, essentially it's just a whole bunch of if and else, right? So as you've studied this before, if and else statement allows you to, a programmer to group various different logic. So you can consider something one as logic 1, logic 2, logic 3, logic 4, so on and so forth, depending on what a condition is. So in case, if an integral value val, right, equals 1, then you have a group of logical statements to be evaluated under this something 1, so on and so forth. So a lot of times when you have a pretty complicated structure where you have a whole bunch of logical compartmentalization involving else if, right? If you have way too many of those, the best practices in software engineering is to convert these into a switch statements, because you don't want to have this giant if and else, right? And a lot of these something 1, 2, 3, they could be like 10, 20 lines, 30 lines of code. You never want to do that, right? But of course you can think about, making these logic into a private function where you can call these functions individually, but that's not the point. The point is for every single if, else if, and else, right? These type of logical conditional structures, you can convert them easily into a switch case. So let's examine some of the details that we see in switch case, and then we'll illustrate this with using a code examples later on. So let's move on to the second part, which is the details. So a lot of times what you do is when you write switch case, in the past, I've seen people using this curly braces to encapsulate these various different statements. And these are your logic, right, associated with this use case number 1 and case 1, right? 1 is where that switch statement evaluates to from an expression standpoint. You don't really need this curly braces, but just to aid understanding, a lot of times what developers will do is they'll indent this, right? So this is indentation, right? So it's basically a tap, okay? So you can tap the entire statements over. So it's understood that, let's say if your statement has maybe 10 lines, and all these 10 lines will be evaluated under this case 1, okay? And then we'll talk about, how to break your switch case, and obviously when the case is over, right? When you're done evaluating all of the statements, the very last one should be a break, unless you intentionally wanted to have the flow of execution to go through the entire cases, meaning after case 1, you want to evaluate case 2, 3, 4, 5, so on and so forth. Otherwise, you'll end it with a break, and break semicolon, okay? So that's it. At the end of the statements, and there is also the default case. So default case is where this is basically the catch-all. And you can think of this as equivalent to the else statement, right, inside the logical control structure. So they're kind of similar. This is what we call the catch-all, okay? So where your logic is not captured in any of these use cases, case 1, 2, 3, 4, 5, you have a default one in case your expression evaluates to something none other than any of these cases you have listed, it'll go into the default. And then in a default one, you don't really need to break, because at the end of the default, you're done. Okay, so let's look at some of the code examples that illustrates switch case to aid more understanding. All right, this is one of the IDEs that we're using online. What you see here is a bare bone C++ program with nothing in it. So we're going to write a simple switch case. Here, as you know, switch case statement evaluates an expression, matching the expression's value to a case value. So let's just say this switch case has a value of 1, right? In general, what's inside the statement could be any integral type. It could be enumerations, could be a Boolean, could be char. In this case, we're using integers, right? So if this integer matches case 1, which is indeed the case, let's just say we're going to see out, right? 1, right? And then we're going to end this with the NL and then break it. We'll do the same thing, right, with case 2. In this case, case 2 will print out 2, and then we'll break it, and then we have a default. And default is the catch-all. Like I said earlier before, when none of the cases evaluates to either 1 or 2, it would just print out this thing, right? So let's just say this is done. You don't really need a break at the end. So this is the complete switch case. So let's run it. This should give us 1 right there, as you can see here. Now, why don't we take this out and say, hey, this is a integer I, right, equals 1. And we use I here, right? And of course, this is not going to change the logical statements that we have there. The execution will evaluate everything into this cout equals 1 on console. Now let's just change this a little bit. Let's just change this to Boolean, right? And of course, we can know Boolean I, right, could be a value. So this basically says I equals true, right? And this will evaluate, but of course, you have to be a little careful. This is a warning, right? Warning doesn't mean that this is an error, which means that the code will still continue. So IDE is actually smart in that respect. It's cautioning you, hey, you have a Boolean here, you shouldn't have a 2 here, but what are you doing, right? So what if we change the char? As you know, char is an integral type, right? It carries an ASCII value, and so it's an integer basically. And it will give you, and so if you convert this into a char, this will fly, right? So a lot of times, you can think about what you need to put inside the switch case. Just remember the switch statement evaluates an expression, matching the expression's value to a case clause, and executes the statement associated with the case. So in this case, there's only 2 statements. One of them is that cout, and the other one is break. So break, right, takes the entire execution out of that entire switch case, exiting the switch case completely. If you don't have break, so what's going to happen is 1, right, after evaluation of line 18, it'll go into case 2, right? And because there's no break, the flow of control is going to simply just go straight down, evaluating all of the cases. So if you print this, you can see by eliminating the break here, the flow of control is going to go through 1, 2, right, and done, right, as you can see here in the output. So this completes our illustration of switch case. Of course, you can always think about converting switch case back into a whole bunch of if, else if, right, and then else. There is equivalent. A lot of times we use switch case because it's a lot easier to visualize versus writing a whole bunch of else if, right, which can get very confusing after going through this entire code for the whole page. It'll be very hard for developers to keep track of what's going on, right, let alone maintaining the code. So this completes our illustrations on switch case.